Okay, air with a certain density, right? It's traveling at 63 meters per second over the top of the wing and going slower on the bottom of the wing. What is the pressure difference from one side to another? So let's draw a picture of this wing. So let's make it a very thin wing, right? Something like this, right? And so up here it's going 63 meters per second. Here it's going 61 meters per second, right? This is situation 1. This is situation 2. So pressure 1 plus rho g h1 plus 1/2 rho v1 squared is pressure 2 plus rho gh2 plus 1/2 rho v2 squared. Now, we're going to get rid of almost all of these terms, right? Let's figure out the pressure difference between the top of the wing and the bottom of the wing, right? So let's go, let's figure out what P2 minus P1 is, shall we? Okay, or P1 minus P2. So, okay, so let's just say that the height difference here is so small that we're going to ignore the change in height. There would be a buoyant force on this thing, but we normally neglect the buoyant force of objects in air. Unless, of course, it's a hot air balloon, right? It's really big. Okay, so I'm going to go P1 minus P2 is equal to 1/2 rho V2 squared minus 1/2 rho V1 squared. This will end up with a negative number, won't it? I set it up with a negative number. That's all right. We'll ignore the minus sign. Okay, so P1 minus P2 is what we're trying to figure out. So 1/2 1.29 times, let's see, V2 is 61, minus 1/2 1.29 times 63 squared. That's going to be the difference in pressure. All right, so I'm going to go 0.5 times 1.29 times parentheses 61 squared minus 63 squared. And I'm getting that the pressure difference is minus 159.96 pascals, right? So why is that? That's because pressure 1, because pressure 1 is less than pressure 2. Where it's going faster, it's less pressure, right? So if we subtract pressure 2 is more. That's fun. Okay. So what that means is pressure 2 is more than pressure 1 if we get a negative number doing that, right? That makes sense. That is, by the way, called the Bernoulli principle, right? Where the air is moving faster, there's low pressure. And where it's moving slower, it's higher pressure. Okay. Keep in mind that people are wont to say that airplanes fly this way. And of course it helps. It helps to have an airfoil like that, right? But you can make a piece of wood fly. Okay, just take something that has no airfoil on it, right? And if you tilt it toward the wind like this, air is going to hit that and bounce downward. It's not going to be wonderful. Your aerodynamics will be terrible, right? So if you look at how airplanes are designed, right? Basically, you've got this wing that's like this. Then that's attached to this long fuselage. In the back, you've got another set of little, you've got a rudder, right? I don't know exactly, right? But you've got another set of airfoils here, right? And so you can do clever things like this. The air can hit this thing, right? And push this part of it down, which pushes, is going to push this part up and tilt the wing more like that, right? So all you have to do is propel this through the air. It bounces off of that, giving a net upward force, and you can adjust the attitude with the tail, right? That's kind of fun. And then to turn, you just have little ailerons or something on the wing that tilt it that way. And if you tilt it and go up, you'll turn right or turn left or something like that. Anyway, that was like the worst explanation, I think, of how airplanes work ever.